Hello, and welcome to the Cloud Multiplier, your show for all things distributed cloud. I am your host, Gurney Buchanan, and I'm, as always, joined by my co-host, Joydeep. Glad to see you, Joydeep. Before I introduce our two wonderful guests from the Volsync team and we dive in, I should say I might disappear from the stream. We've been having some technical difficulties, or I should say live technical difficulties, so Joydeep will be taking over as host if things go south. So without further ado, let's dive in and talk to our two guests. Today we have John Strunk and Tesshu Flower from the Volsync continuity of Red Hat. I think we disconnect there.
You are still connected though.
Okay. It's warning me. So it's glad to have everyone here today. Let's go around the room as always. We'll start with John. You want to tell us a little bit about yourself and what you do the Volsync project and beyond?
Yeah, sure. Thanks, Gurney. So yeah, I'm John Strunk. I've been at Red Hat for about 5 years. And pretty much all that time, I've kind of been working at the intersection between containers and storage. And Volsync is kind of the latest project that I've been working on. It's something I'm looking forward to sharing with everybody today. I think it kind of fills a big gap in that space out there of kind of allowing us to easily move data from, point A to point B, particularly in, multi-cloud environments and stuff like that.
Awesome. I'm very excited. I haven't played with Volsync much, but I surely have heard a lot about it from talking to both of you. Tesshu, you want to tell us a little bit about yourself as well?
Sure. Thanks, Gurney. I'm Tesshu Flower, and prior to joining Red Hat, I was at IBM working on operators and policy kind of operator work. But I've been at Red Hat. I just realized it's just over a year now. I joined beginning of last October. So I've been working with the ACM team and John as well. And it's been really cool to learn Volsync as I go. It's a really cool project. And I'm still just getting started with contributing to it, but it's been really great so far. And you'll see as we show you.
Yeah, that's awesome. So, and a little bit of background here. Joydeep, myself, especially Joydeep, as I was working through the connection issues, was asking so many good questions about Volsync. So hopefully, Joydeep, you remembered all of those for the show today. But I think to set the stage, all I know about Volsync is that we were scheming to run a multi-cluster, multi-availability zone. I think it was a Minecraft server a while ago with Oleg. I should give a shout out with Volsync for data replication. That being said, I think today we're going to be talking about not only that, but also the disaster recovery, business continuity side of things. What I know isn't there something to do with ODF with Volsync as well? Some interop and some work there as well.
Yeah, there is. There's definitely some work going on there. ODF has been busy putting in disaster recovery capabilities for the storage that they provide with that. I know, Tesshu's been very involved, sort of going between, Volsync and the ODF engineering teams. And so right now, the Raman operator and orchestrator is something that we're going to mention a little bit later, but that largely comes out of the ODF team. We're working on a collaboration right now to provide disaster recovery for CephFS, right, which is part of the ODF suite, and to use Volsync to do that.
Wow.
And that's something that Tesshu can probably provide some more detail on, because I know he's really been working with them.
Yeah.
Sure. Yeah. I could talk about that when we get there, but
yeah,
it's been great.
I think this is the first data persistence related discussion we've had on the Cloud Multiplier, which is really a great thing to talk about now that bunch of applications running on them that may or may not be business critical, maybe the data might be important as well, which is really your specialty, really.
Yeah, so getting the moving applications around is fairly easy, right, across clusters and stuff like that, because it's kind of a handful of YAMLs and you can bring it up, right? But once you've got the data involved, it really becomes difficult to kind of orchestrate all that.
Awesome. Well, I don't know if, do you want to give us a quick primer? Because I'm curious at this point of what we have going on with Volsync and where I use it in my day-to-day life to make sure that things stay persistent and online when things go down.
Yeah, sure. So I've actually got some slides that I brought, and this would be a good time to kind of kick it off with some of those and give an overview.
Yes, I'm sure we'll have plenty of questions along the way.
All right. Yep. Just I will get started, and you can interrupt me wherever in there, and we'll take those questions. All right. So hopefully you're going to get some slides.
Should be good to go, I think.
All right. Great. So so what I've got is kind of just a quick overview deck, sort of set the stage and talk a little bit about Volsync. And then later on, Tesshu is going to run through a demo and actually show it in action. So before I get really into the details of Volsync, what really drove this is this notion of application migration, right? So a lot of organizations have multiple clusters now, right? Whether it's just different regions in the same cloud, or they're actually multi-cloud, where they're trying to spread their eggs across multiple different cloud providers, and then bringing in their on-prem data centers, in addition to that, right? And they need it to all really work together, and they need to be able to move their applications around between those clusters. And there's multiple reasons for that, right? It may just be simply a case of trying to minimize cost, right? Or they want to deploy their application near where the customers are, so that they can optimize the delivery of that application, the service that they're actually providing. And then there's sort of the more traditional case where they're just after simple disaster recovery, right? I've got 2 sites, and I need to make sure that if something happens to my primary site, I can get my application back up at the secondary. And whenever you start to look at this sort of application movement, it's reasonably easy with stateless apps, right? In sort of a Kubernetes or OpenShift environment, your app is largely just defined by a handful of YAML, and we've got these great GitOps workflows, and so it's pretty easy to like in advanced cluster management, just sort of tag my app and tag my cluster, and hey, everything moves, right? But as soon as we start and introduce data and have that sort of persistence tied to the application, now things get a lot harder, right? Because whenever I want to move my app from point A to point B, I gotta get the data across to that new location as well. And if what we do is sort of look at how data is kind of moved today, or how we've traditionally done the data movement, what we've really done is relied on the storage system and storage system vendors to provide support for that data mobility. And that sort of comes about because of historical reasons, right? Because kind of how we wanted to do it in the past, we really had 2 data centers, and it was really about disaster recovery, right? Replicate my data from data center 1 to data center 2 in case something bad happens. And the problem with this, in today's environment, is number one, we're relying on that storage vendor to provide the data mobility for us, and so we're kind of locked in, right? And what that means is that we're stuck deploying the same storage system everywhere, right? And that just doesn't work in today's environments, because you go and you've got cloud deployments, And those look completely different than, how you would deploy, on-prem. And so saying, well, you've got to use the same storage provider in both places, that just doesn't make sense, right? Because it's not going to be the right solution in all those different locations. And as well, we've got sort of this expanded set of use cases, right? Traditionally, it was just DR, right? That was why we cared about moving data traditionally. But now we want to be able to move it, to be closer to our customers, or maybe we want to send data out to the edge. And those look a lot different than just replicating for disaster recovery. And so we really need a good bit of flexibility with it. And so that's really why we went and created Volsync. Right, so what Volsync is it's a Kubernetes operator that is designed for data mobility. And what's neat about it is that we only rely on Kubernetes functionality to do it. And so what that means is that we can move data around totally independent of the storage system, right? And so you can do things like replicate data between, two storage systems that are from completely different vendors, or from the cloud to your on-prem data center, or between two different cloud providers, right? And it doesn't matter; it works the same in all those situations. And what we did, because of all these different use cases, is we designed Volsync around what we call data movers, right? And you can build additional data movers and plug them in if you've got a new use case. And so what you can do is, for all the various use cases out there, right, from like disaster recovery to like data distribution to the edge, you can choose the correct data mover that sort of fits your use case the best, right? And so let me tell you a little bit more about these data movers. So we have, whenever you configure Volsync, it's based on two different types of Kubernetes custom resources. Right, so there's a replication source and there's a replication destination. And within those, you then specify exactly which data mover you want to use. So for example, we have an rsync-based data mover that's great for sort of one-to-one replication of your data. So you would use this if you're trying to do like disaster recovery, right? So it'll take your source volume, replicate it over to the destination. But let's say you want to go and replicate your data from like a main data center out to a bunch of edge locations, right? That's probably not the data mover for you. Maybe you want to look at the rclone-based data mover, right? So what that one does is it'll take the data in your source volume and send it to an object store, and then your destinations will pull the data down from that object store. And so this works great for these like high fan-out situations where you're trying to send data to a bunch of edge clusters, because you're not putting all that load on your central cluster, and all the edges can kind of pull independently. We've got a third data mover that's based on Restic that's just for simple PV data backup, right? So imagine you've got your GitOps workflow that's great at deploying your application, right? So your application, it's in version control, all defined with your YAMLs, but you need an answer for the data that's actually in your persistent volumes. And this is really where Volsync's Restic-based mover shines, because it's not worried about all those other YAMLs. It's only focused on the data that's actually in your volume. And so it pairs up really well with the GitOps workflows. And then the most recent data mover that we added was one based on an application called SyncThing. And that one's really different than the others, because what it does is it actually allows you to share live volumes across sites. And so you can actually have like active applications across sites with SyncThing running in the background, synchronizing data across those volumes, right? It does it with eventual consistency, but it's something that, there's a sort of a certain class of applications out there that can handle that, and it provides kind of a very unique capability. So,
John?
This is pretty incredible. Go ahead, Pradeep.
Yeah. two observations. I mean, first of all, you took a long time to utter the word Volsync, which was great. You were explaining the general use cases which resonate, which are absolutely great. Now, one statement is that we do know today that customers are going multi-cloud, not only multi-cluster, they're going multi-cloud, and avoiding vendor lock-in is one of the big priorities. There are several others. That's true. And so this technology is helping them even more. You are not getting locked into a storage provider. So this is giving them even more flexibility, right?
That is absolutely right. So, the capabilities that Volsync is built on, it's all standard Kubernetes functionality, right? So, we replicate data that's in persistent volumes, and whenever the CSI interface, the container storage interface, came in, I don't know, a year or two ago, probably 2 years at least ago, that brought in sort of a standard way of cloning data volumes and taking snapshots. And that's really what Volsync builds on. And so, if your storage provider has a CSI plugin for Kubernetes, you can run Volsync on top of that.
Okay.
Right. And so it really is independent of the underlying storage.
Okay.
Yeah.
And the second, sorry, Gani.
Oh yeah, go ahead.
The second stuff, and you probably will get to it later. You are using the word persistent storage, database store, etc. You have not used the word database at all thus far. There is no database. So maybe you will bring it into the picture later. If so, let's wait for it.
Yeah, I mean, I don't have anything specific to databases in the talk at all, because really, Volsync is, it's going to replicate whatever you choose to put into your Kubernetes persistent volume, right? Whether you're, deploying a simple app that writes a bunch of text files into a PVC, or whether you're running something like, MySQL that's, putting its database into the PVC, right? Volsync doesn't care. It's just going to replicate, from point A to point B.
Fantastic.
Yeah. So what it ends up being is a truly hybrid solution a truly hybrid and multi-cloud solution by being fully agnostic to both the workload and the platform. And then it gives you an entire toolbox that you have in this really great slide of different ways that you can sync or back up data. I can imagine syncing in a lot of ways is almost like your eventually true database. It's a similar thought where within this amount of time, it'll be consistent across a fleet of clusters, which especially for 1,000 cluster scale edge applications, you're reaching a point where no matter how well architected you're able to use and synchronization, you're going to end up with an eventually true system one way or the other.
Gurney, we lost you a bit in between, actually.
Yep.
I just got a message in the discussion about that.
Yeah.
Yeah, so I will try to get them a little better. I was just saying you have a truly a system that is eventually true, and if you have an edge deployment, every system is eventually true because something's sitting out in the woods somewhere.
Yep. So you know what? That was some great questions about sort of the, how we send the data around. I've got like 2 more slides. And the next one up actually talks kind of about how the rsync mover actually works. And I think that'll probably kind of fill in some of the details for folks. So, if we think about taking an application that, maybe we want to move from, a primary site over to a secondary site. What I'm going to do here is show an example of, how you would use Volsync with the rsync mover to make that happen, right? So imagine we have an application deployed here that's storing its data into a PVC on our primary site, and we're going to replicate that, right? So what we do is we run the Volsync operator on both clusters, and it's going to coordinate the movement of the data. So what we do to configure it, we create a replication destination object over on that secondary cluster. And when the Volsync operator sees that, what it does is it sets up the resources over on that secondary site to receive the incoming data transfers, right? So that amounts to a volume to receive the data, as well as a receiving data mover, and then a network endpoint to take the incoming transfers. Over on the source side, what we do is we create a replication source object and point it at that PVC that we want to replicate. Volsync will then see this, and then what it will do is it'll make a copy of that volume so that we get a nice consistent point-in-time image. And then it will start up the rsync source data mover to copy that volume data across the network over to the destination. Then once that transfer is complete on the destination side, Volsync takes a snapshot over there to preserve that point-in-time image, right? And this sequence can happen based on a schedule or manually, depending upon how you configure the source object. And so we're constantly updating that consistent snapshot over there on the destination, so it's ready, whenever we want to use it. And so then what that means is whenever we want to move the application over to that secondary cluster, we can just take the most recent consistent snapshot, turn it back into a volume, and bring up our application. Now, one thing I do want to mention is, this slide and most of the talk so far has really been focused on the data movement itself, right? But that's not really what folks are after, right? What folks are really interested in is being able to move their application, right? Which is more than just the data, right? Because there's some coordination involved. And so that's really where this full stack, as we talked about at the beginning of the show, where the full stack of advanced cluster management plus Raman plus Volsync comes in. Because ACM, it gives you that multi-cluster view to help you figure out where you want to run your applications and keep track of all that stuff. And then the Raman orchestrator is really there to manage the application level movement, right? So for example, whenever you go and deploy your app, it's Raman that's responsible for, as the app comes up, setting up the replication relationship between that source and the destination, right? So it goes in and it creates that replication source object and the replication destination object for you, so that the replication gets started and it runs in the background. And then whenever it comes time to actually relocate your app from your primary to your secondary cluster, it's Raman that then kicks in and shuts down the application on the source side, right? Assuming that you're doing a controlled movement of your app. It shuts it down on the source side. Then it triggers Volsync to take sort of one last final sync of the data so that we're sure that all of the data gets propagated over to the other side. And then once that has completed, it spins up the application on the new site, right? And so it's really that whole stack that gives you the experience that you're looking for. So that's the end of my slides. And so I think what's really next. We can pause for some more questions, but what's next is going to be I'm going to turn it over to Tesshu, and he's going to run through a demo showing how this thing actually works.
So by the way, Gurney is very much connected. He's just not turned on his video. So John, this is active passive migration, right? And I might use that for various reasons, like you said. It might be for HIDR. It might be because the load was running in maybe in Amazon. I want to move it to Azure for whatever reason, or vice versa. Okay. And do we have any benchmarks on how much time it takes related to the data volume? Have you guys done any kind of benchmarking?
So we haven't really done a lot at this point. And it's something that's difficult to put a number on because there's so much that goes into how that's to how long it's going to take. But the different data movers, they're based on kind of well-known data movement applications out there, right? rsync, rclone, restic, and so if those applications sort of fit your workload, you're likely to have a good experience with Volsync as well. and sort of the same kind of caveats, and benefits apply, right? So like if you look at rsync, in order to do a transfer, it has to analyze the file system and figure out what has changed, right? So if you've got like 5 million objects in your volume, that's probably going to take a little while. On the other hand, if only a little bit of data changes, one of the benefits of rsync is that it calculates, diffs and only sends, a little bit of data, right? And so, that's one of the nice things about getting to choose the different movers. You can choose the ones that fit your data the best.
Right. That's very critical. And I guess you also mentioned that we could schedule it. I mean, we probably will know when we are doing this, so we could schedule it so that things continuously run, so that the final flip is not that much expensive, hopefully.
Exactly. Yeah. So that, that replication source, you'll typically, whenever you configure it, you set it up with a schedule. It's basically cron based. So you can say, run an iteration every 10 minutes, every 15 minutes, whatever it is that works for you. And then, whenever you trigger that final movement, with ACM and Raman, it just goes and, it'll kind of be an immediate out of cycle sync, but you're only sending that, what has changed since that last scheduled movement, right? Or that last scheduled iteration. And so, that part can actually be pretty quick.
Fair enough.
All right. Should I do the demo now?
Go for it.
Questions before I start? All right. Hopefully Gurney's still there.
He is still here.
You don't see the screen yet, huh? Well, let me just say what I'm going to. Oh, there we go. So I'm going to show exactly what John was talking about. The Raman scenario, which is, Raman again is like a collaboration. It's done by the ODF team, but we've been collaborating with them to integrate with Volsync. So they have this Raman solution that could do Ceph storage, for example, but Ceph is managing the replication between sites to do things like CephFS or other CSI storage. That's what Volsync brings in. So essentially, Raman is leveraging ACM in terms of the application. So it's an application deployed by ACM, but Raman can insert itself and control the placement of the application. So what we do is you set up Raman to say, I have a primary cluster and I have a fallback cluster. And now it can set up, in this case, Volsync, to create the replication source and destination on both sides. And I'll show that. And like John was saying, I'm going to show a relocation here. So that's a planned failover. And the idea behind that is I can show, inserting some data in the PVC. Then I can do a relocate, which will quiesce the app, do a final sync. And then we should be able to see the app come up on the other side with the data that I just wrote. So I have a basic DocuWiki app here. So this is an ACM view of the application. We can see it's deployed from Git. If we look at the application topology here, hopefully this is viewable. It's a bit small, but we can see the application. This is not too complicated. It doesn't consist of too many things, but I've got a deployment. There's a pod down here. The main thing that makes this a stateful app is I have data written to the PVC here. And now what we do is we tell Raman, I want you to protect all the PVCs with a specific label. So my app is deployed with a specific label that Raman is looking for. And then when it sees a PVC in the namespace with that label or set of labels potentially, it'll know to protect that PVC using Volsync. So this specific app here, it has a route. I'm just going to do that. So again, we're using DocuWiki as an easy way to see, here's an app and there's some data, and I'll be able to change the data. So right now I can add something here. if I save this, so again, if we had just run a failover, what would happen is we would cut over immediately, and we would get whatever was in the latest snapshot that was sent to the destination side. Since I'm going to do a relocate, it'll take a bit longer, but it'll quiesce the app first, take a final backup, so we have a good, clean final backup of all the data, and then move the app over. Because in a relocate, the time isn't the utmost concern. It's we want to get a final copy of the data. I'm going to show console again while I do this too. Hopefully this is readable, but we have, for example, the top is my local cluster where I'm running the app. I should show you that in here too, actually. So we can see here the app is running on my local cluster. So I have a local cluster and I have another cluster called managed one. Okay, so the top console is my local cluster where I can see the pod. This is my DocuWiki pod at the top here in the deployment. We can see a PVC. The PVC is just called DocuWiki. But we can also see Raman set up a replication source. So this is using rsync. So it's the one-to-one replication. We've got a replication source set up for this DocuWiki PVC. And on the other side, so this is my other cluster, we can see it's running a replication destination. So we can see there's already a previous snapshot from the last sync. The other thing I should mention is this is running on a schedule. So you can see the last sync was 4 minutes ago. It's set to run every 10 minutes now. That's configurable in Raman itself. But so it'll start, if we don't do anything, it would do the next replication at 1:40 Eastern. So what I'm going to do is run the relocate, and we should be able to see some of the parts happening in motion here. So I'm just going to, this is essentially, I'm going to update the DRPC, which is a DR placement control. So that's a CRD for Raman that's governing this whole application. I'm going to tell it to relocate. And so it's going to start relocating to the managed one cluster. So the first thing it does, though, you can see it's already happened, is that I should highlight this, the app has gone away on the source. So it's quiesced the app at this point. You should be able to see that here. So we can see the placement's been updated. Raman's updated the placement to not place it anymore, which is undeploying the application. And then what it's going to start to do is, once it's decided the app is down, I'm going to run a final sync using Volsync here. So it's actually running right now. So these are some of the intermediate containers John was talking about. So it's created, this is created by the replication source. And we can see it's going to start replicating to the other side. So we just need to give this a sec. But this pod here is essentially a pod that's going to run our sync from the source side to the destination to give us a final sync. And like John was saying, it's not sending the entire data over. It's just sending over, here's the change between our last cycle. So that should just be essentially the text I wrote into DocuWiki. So it's already started happening here. It will have completed the final sync because it's cleaning up on local cluster already. So the next step is it will restore the PVC on managed one. So this is my other cluster. We should see it restore the DocuWiki PVC from the snapshot. And this would be the latest snapshot. So we're just going to have to give that a minute. You can see in the UI that at the moment the application is not placed anywhere. The other thing I can show you is so because the app is down, this old route is down. Okay, so actually we can see the DocuWiki PVC has come up now. So this is a PVC that Raman has restored from the snapshot. So this will be the latest copy. It'll be in pending state in this particular case because the storage class has wait for first consumer, but now it's starting the app. So we can see here's the DocuWiki pod starting. You can see if it gets updated here already. And we can see, so the placement has been updated to place on my managed one cluster, and we just have to wait for the app to start now. So at this point, we're just waiting for this pod to come up, but it'll be using this PVC that was restored prior to starting the application. Okay, just give it a minute here. Essentially, once the app comes up, we should see all this go green, and then we can take a look at, what's in the PVC itself. Looks like it's just come up now. This UI might take a sec to refresh, but I can probably access it anyway. So we can see that the data was copied over, and my updates made it over to the other side. The other thing I should mention, so essentially the relocate is essentially done at this point, but now what Raman's going to do is reverse the flow. So it's going to say, you know what, managed one is my primary. I'm going to start creating a replication source on this side now and a replication destination on the other side, so that I'll be able to fail over the other way. So essentially that's what's still happening here. We've created a new replication source and a new replication destination. So we've reversed the flow here.
Fantastic.
That's about it. I mean, we could wait for that to finish, but it shouldn't take too long.
If this was a room, we would have all clapped. I was holding back my questions till you completed.
No, that's fine. Ask away.
So I have an indirect question, and hopefully it's just my ignorance, but this is a show, and we have users who might be a little shy and not asking the question. So what kind of network communication do we need between the two clouds? So it's rsync. So rsync is on the TCP layer. What kind of firewalls, ports, things we need to open?
So in this particular case, what Raman is also leveraging Submariner in this case. Rather than, you can set up Volsync on its own. You can set it up. The service is configurable. You can set it up as a load balancer, which would be externally accessible on your cluster, so that the two clusters can communicate over that external load balancer. I don't know if I just said router load balancer, but it's a load balancer. But in this case, Raman's leveraging Submariner on the system. So it's using an internal cluster IP service on each side. Yeah. So they're communicating via Submariner's setup. So it's going through the Submariner tunnel.
Yeah, that's exactly what I was trying to ask. Yeah.
Great.
Okay, now we have got a real question here. I don't know, Gurney, if you can put it up, but the question is, can you do Volsync without a CI snapshot that is just restic, using restic?
Yeah, so whenever you configure Volsync, one of the options that you choose is, like, on the source, how we get that consistent point-in-time image to serve as the source for the replication. And then there is another choice over on the destination for, how do we preserve the results of each iteration. And whenever you're using a CSI driver that supports either snapshotting or clones, on the source side, you can use those, right? So the recommended choice is, if your CSI driver supports clones, that is directly going from PVC to PVC, you should use that, because that tends to be the fastest and most efficient. But certain CSI drivers don't support volume cloning. So for example, the AWS CSI drivers for EBS, they do not support volume cloning. And so you can use the copy method, as we call it, copy method of snapshot. And in that case, it goes and creates a snapshot and then takes the snapshot and turns it back into a volume. And that's how we get our consistent image on the source side. But if you've got a CSI driver that does not support clones or snapshots, we have a copy method of direct, where it will actually start the mover against your primary PVC and just send the data straight out of there, right? Because there's there's no easy way to get an actual copy of the volume if the CSI driver doesn't support clones or snapshots. And so, that's kind of meant to be there as a fallback. In the case that you're using a storage provider that doesn't do that, you can still use Volsync. The sort of the guarantees that you get aren't quite as good because you're essentially copying data out of a volume that could be changing underneath you. But you can still get you can still get some of the benefits. Likewise, on the destination side, you've got the choice of copy method of snapshot or copy method direct, or none is kind of a synonym there. And that's just at the end of an iteration, do we try and take a snapshot, or do we just have that volume there for use? Mm-hmm. And so again, it's do I have the CSI capabilities to preserve it, or do I need to just use the volume that's there? So yes, we've got that configurable, to fit all sorts of scenarios.
Fantastic. Okay, Dajun, I hope that answers your question. And thanks, Gurney, for posting the link to the episode that we had a few weeks back on the Submariner. So that's a ready link, how the connection is being made between these two clusters. Looking at the watch, it's probably time to bid goodbye and play our outro. And before we go, first of all, thanks to you guys both. This was awesome, John and Tesshu. And before we go out, we will see you in the next 2 weeks. We will talk about something very small, but it'll be very big. Pardon the pun. And with that, Gurney, why don't you play the music?